All right. So this is the one that we're up to, the second example. So just like before, we find the GCF, right? Sorry, we find the GCF. Now notice there's a non-zero constant term, right? 16. 16, in other words, has no x's with it. Well, that tells us that the GCF can't involve x. In other words, as we've said before, since there's a non-zero constant term, m has to be 0. Okay, that's good. Well, what about the coefficients, though? 9, 36, 4, and 16. We can list their factors. I mean, generally, you don't have to list all of them. Once you have any two that only have a common factor of 1, just like 9 and 4, that tells you right away what's going to happen here, that the greatest common factor, in fact, the only common factor among these wonderful coefficients and the constant term is 1. So going back to this b here, which is the greatest common factor of the coefficients and the constant term, it's 1. So our GCF then is just 1 times x to the 0, which is 1. Okay, so the GCF is 1. Do we factor it out? Well, no. I mean, you could factor it out if you want. It's not going to get you anywhere. Okay, so what do we do then? Well, factor by grouping. We do the next step. We form these two groups, as you can see. And now we get the GCF out of each of these groups. Okay, so let's handle the first one. Okay, well, the smallest exponent of x is 2. So that GCF thing, that m is going to be 2, right? Now, it was on the previous slide, but you have the slides now because I posted them and I emailed them to you. 9 and 36, their biggest common factor is 9 itself. 9 is actually a factor of 36. So 9 is the greatest common factor of 9 and 36. And so our b is 9. So we have our b, we have our m. Altogether, we have the GCF of this, 9x squared. That's good, that's cool, that's fun. Okay, now that we have that, we factor it out. And as before, you put it in front, you divide, you have a sum here. So you divide into each term in the sum, as you can see. And then we get this, right? Because here, the 9s cancel. For the x's, you subtract the exponents, so we get this. Here, the x squares cancel. 36 over 9 is 4. Good. Now that's the first group. For the second group here, same thing. We have to get the GCF. So again, as before, there's a non-zero constant term. M is 0. 4, but just like with 9 and 36, 4 is a factor of 16. So since 4 is a factor of 16, 4 is the greatest common factor of 4 and 16. So we take b to be 4. Hence, the GCF of this thing is going to be 4. 4 times x to the 0, which is 4. Although, again, x to the 0, 1, that's not really precise, but for now it's okay. So we have the GCF. What do? Factor it out. And that's what this does. Okay, so that's what we get. Good, good. Okay, and again, just like before, when you factor, you divide, and so on. And here you can see that the 4's cancel. And here 16 over 4 is 4. So We get that. Okay. Now, let's put those, now, putting this stuff together, we get this. Excuse me. So notice that there's a common factor of x plus 4, right? In parentheses, x plus 4, right, is there, and it's in both. That's what we want. We want, after factoring out the individual GCFs, to have something in common. Okay, so what do? We're going to factor that out, and that's what I'm doing here. You know, whatever's in common, you're going to take that out, right? But again, you get what's left over, right? And how do you get what's left over? You divide, right? Now, x plus 4 is the entire factor, so and we have to divide that into each term. But it's not that bad because, as you can see, there's cancellation going on, and we get this, right? These cancel. We have 9x squared. These cancel, and you're left with just 4. So we end up with this thing. And we have to stop here because, not with the lecture, I mean, but with this problem, because you can't factor any further. So here we stop. Okay, so that's our factorization of this. And that's the technique of factor by grouping. Now what we're going to do is see another technique. Let me just pause the video and then start it up again.